Hello everyone, I'm Mr. Furlong, and today I'm going to show you how to use these models to write formulas and name compounds. On your table you have all these small pieces of paper. Some of them are blue, some of them are yellow, they're all different sizes. But if you take a look, all the blue ones have a plus sign. They all have a positive oxidation number, and they're of different lengths. Some are 1 plus, some are 2 plus, some are 3 plus. And you have the yellow ones, those all have negative oxidation numbers of different sizes. Some are 1 negative, 2 negative, or 3 negative. You have a worksheet that looks sort of like this. And we are going to combine the positive ions, which they're actually called cations. Kind of a funny name, I know. And then there's an anion, which are the negative ions that make up this compound. The first one is aluminum, and we're adding chlorine to it. So find the aluminum, that's one of the big ones, that's a 3 plus. And then find chlorine. That's one of the smaller ones. That has a oxidation number of 1 negative, and in this case they're not showing the 1 for us. In order for us to complete this chart, we want to make sure that the charges are equal to one another. So for instance, if aluminum has a charge of 3 plus, we need to have a charge of 3 negative to equal it out. Chlorine only has 1 negative, so we need to add another chlorine, which makes that up to 2 negative, and we have to add a third chlorine, a total charge of 3 negative. Now take a look at what's happened here. The blue strip and the 3 yellow ones are the same size, so they fill this table out. So the number of cations, we have just 1 cation piece of paper, and we have 1, 2, 3 anions. The total positive charge is 3 plus, the negative charge is 3 negative. The formula then would be AlCl3. So again, it kind of takes place of that crisscross method because we have just the 1 aluminum and then the 3 chlorines. Now the name of this is aluminum chloride. Doesn't look too good there. How you get the name, you take the cation, that stays the same, and then you take the anion and you change the ending to IDE. So aluminum and chlorine together make aluminum chloride. Let's do another one. Sodium and oxygen. So find your sodium, that's 1 plus. Find the oxygen, that's 2 negative, so they don't equal out, so we need another sodium. Now they're equal. And so we have 2 cations, only 1 anion. The total cation charge is 2 plus, anion charge is 1 negative. The formula, Na2, because we have 2 sodiums, and 1 oxygen, so it'll just be O. The name, sodium oxide. We just drop the ending off of oxygen and we change it to IDE, sodium oxide. Let's take a look on the back side. We're going to add potassium and sulfate. So this is a polyatomic ion. So we find potassium, that's K+. Sulfate is SO4, that's 2 negative. They don't equal. So that means we need another potassium. So how many cations do we have? We have 2 cations, only 1 anion. The total positive charge is 2 plus. The negative charge is 2 negative. The formula is K2SO4, so we only have that 1 polyatomic ion. We don't need parentheses. The name, these are easy to name because nothing changes. So this would simply be called potassium sulfate. Right? Pretty simple. All right, well, let's do another one. Let's take magnesium, which is 2 plus, and phosphate, which is 3 negative. Now they don't equal up, so we need to add another magnesium, another positive. But if we do that, so we got another magnesium, but now there's a greater positive charge than negative, so we need to add another phosphate. Well, I just had another phosphate, but now it's not even with the positive, so I need to add another magnesium. Finally, they're the same. So let's write this down. The number of cations, we have 1, 2, 3 cations, 2 anions. My total positive charge is 2 plus, 4 plus, 6 plus, and my negative charge is 3 negative, plus another 3 negative, that's a 6 negative. The formula would be Mg3, because I have 3 of them, and I have PO4, but I have 2 of them. So I got to put my parentheses there and put a 2 on the outside to show that I have 2 PO4s. How I would name this, again, it's nice and simple. It's just magnesium phosphate. We don't have to change anything when we're using polyatomic ions. Let's do one more. Let's take copper 2, so we know it's a 2 plus, and hydroxide. Now that's a 1 negative. They don't equal one another. So that means we're going to have to add another hydroxide, and now they're equal. So let's fill out our table. We have 1 cation, that's the blue one, 2 anions. The total positive charge is 2 plus. The total negative charge is 2 negative. I would write this as Cu. Now I have these 2 hydroxides. So remember, I got to put that in parentheses then. And on the outside of that, I'm going to show that I have 2. And then I will simply name it. This is copper hydroxide. Don't have to change a thing. And that's all there is to it. So I'll give you a chance to finish the rest of these. If you have any questions, just raise your hand and I'll be around to help you.